Oh, that's interesting. Well, I
Uh,
wanna I wanna have a fun time. I'll press the button. Oh, oh, hey, I'm at school. Oh, Michael, hey, how are you doing?
I'm good. How are you?
Well, I'm assuming since we're here, we probably want to go over our problem that we
Yeah.
were assigned. So we had 6.10, and the problem is to determine the difference of Cp minus Cv for the following liquids using the data provided near 20 degrees Celsius.
And we actually had it was 6.10 E, so just one part of the chart, and that was for chloroform. So here's the data for that from the chart. And so to begin, again, right away we decided to convert the 20 degrees Celsius to Kelvin. Of course, that's 293.15 Kelvin. That's just a start. And at the top of the page, we wrote down some useful relationships and equations that we were given to know um, uh, to help us, of course, derive C to help us derive CP minus CV. And so the way we started off this to start off finding the relationship between CP and CV is we noticed at the top you can see that CV over T is equal to DS over DT with constant V, and CP over T is equal to DS over DT with constant P. So um, between the two, DS is what is the same. So we realized that we should derive in terms of DS, and I'm sorry, we should have something to do with DS. So the way we did that was we derived DS using the expansion rule, where it says DS is equal to DS over DT P of dt plus DS over dP T of dP. And as you can see, we already have a relationship in the top left where it says ds over dpt is equal to negative dv over dtp. So right away, we're going to go plug that in. And then also we have ds over dtp is equal to cp over t. So from there, we plug it in. And now what we need to do is, again, we have CP, so we need CP and CV. So to do that, we realize that, okay, we have ds is equal to this whole equation. So if we derive in terms of dt, we can go all the way back to the top, and we notice that ds over dt with constant v is equal to cv over t. And that really helps us here because now we are left with cv and cp, and of course the rest of the equation. So from there, we were left with cv over t is equal to cp over t um, times dt over dt v. And we know that dt over dt with constant v is equal to 1. And then this is also minus dv over dtp times dp over dtv. So with all that, we are left with, right here, we have cv over t is equal to cp over t minus dv over dtp times dp over dtv. And to get cv and cp by itself, of course, we multiply by t. And over here, we're left with cv is equal to cp minus t times dv over dtp times dp over dtv. And then, of course, the way to, of course, get cp and cv I mean, next to each other on the same side of the equation, we just manipulate it and we get cp minus cv. I think it's is it yeah, I think it's over here. Hold on, sorry. I think it is. Anyway, yeah, we put them next to each other. We put CP minus CV is equal to. Do we have?
Yeah, it just goes right up
Oh,
to the top right here.
okay, it goes right to the top. Sorry about that. Go ahead.
So now we go from here. We have Cp equals Cv plus T, dV over dt with constant P, and dP dt with constant V. Um, Luckily, we know that we have two equations here that we can derive. So we have kT is equal to negative 1 over V times dv dp at constant t, and that can be manipulated so that you get the equation right over here, which will give us negative kt over. Oh wait, sorry, not my bad. You want to go with the alpha first. You multiply the v over, which will get you alpha v equals dv over dt constant p. You will plug that into the equation right here, giving you cp is equal to cv plus t alpha pv multiplied by dp dt constant v. Then you can go through here the equation that we derived in class, where you have the equation negative kt over alpha p is equal to dp over dt constant v, which is equal to alpha p over kt. You will end up plugging that equation all the way back in, getting yourself cp is equal to cv plus t times alpha times v. Multiply that by alpha p over kt, and you once multiply that through, you get cp is equal to cv plus t alpha squared v over kt. So we now have that equation right there, and this we will then go through and plug all of the numbers that we have in from the beginning, making sure to not forget to multiply by negative 10 or 10 to the negative third and multiply by 10 to the negative sixth for kt and alpha. And we have, so we end up with 293.15 multiplied by 1.273 times 10 to the negative 3 squared multiplied by 119.38 divided by 1.2832. All of that divided by 8.3 times 10 to the negative fifth. And we will end up with 4.06 joules per mole Kelvin. And we ended up using 8.3 because we changed it from bar to megapascals here, which is why we used 8.3 times 10 to the negative 5 instead of 83 times 10 to the negative 6. But yeah,
And
that's how we
sorry,
go
sorry,
about the problem.
real quick. And also the V, just to clear up any something, it's just MW, or molecular weight divided by density, just for any just to
Yeah,
clear up
yeah,
everything.
of
That's
course.
of course in the chart. And that should be it.
Yeah, that's all right, Michael.
Yep, that is it. Yay!
This was a fun time. All right.
This was a great time.
I'll see you next time, I guess. Bye.
All right, bye. What are you waiting for?